On top of the standard events supported by the browser, such as touch start and touch end, Sencha Touch adds custom events that can be used, including swipe, pinch, rotate, and many more. If you want to make your application respond to these events, you will have to learn how to create event listeners. This screencast will show you how. The code used in this demonstration can be found on GitHub. I've created a separate branch for every checkpoint, so each time you see a card like this one, it means that you can check out a snapshot of the code in its current state at that point in the screencast. You can find instructions on how to view these snapshots in the repository's README file. When you create a component in Sencha Touch, you can attach event listeners with the listeners property. This accepts a configuration object, which can specify events and their handlers. This example looks as though it should log a message to the console whenever the panel is tapped. But if I open this in a browser and click on the panel, you'll see that nothing happens. The reason for this is that the panel is deaf to events that happen in the document object model, or DOM for short. When you create an object in Sencha Touch, such as a panel for instance, you can think of it as being represented in two separate spaces. The panel itself can be seen as an abstract model existing in an object space. But the panel also has a physical manifestation in the document object model. It is represented here by two HTML divs, the element and the body. These two div elements exist in the DOM, which means that they are capable of responding to any of the events that are usually associated with an HTML element. That includes click events, mouse overs, mouse outs, and so on. The panel object is represented by these two div elements, but it does not exist in the document object model. So the click and mouse over events cannot be captured by the panel itself. If you want to respond to any of these browser native events, then you should attach a listener to either the panel's element or body div. I can fix my original example by attaching the handler to the panel's element. The tap event should now be fired when I click on the panel, logging a message to the console. Note that I could attach this handler to the panel's element or to its body. Both of them are capable of listening for DOM events. In the example, I attached the event listeners using the listeners property at the point of initialization. Alternatively, you can add listeners after creating an object using the addListener function. This can be invoked in a couple of different ways. You can pass it a single argument, which should be a configuration object, just like the one that was assigned to the listeners property during initialization in the previous example. Using a configuration object allows you to attach handlers for multiple events to the same object in a single step. The addListener function has an alternative format, which accepts up to 4 arguments. The first argument is a string representing the name of the event. The second argument is the handler function. You can pass an optional third argument representing the scope, which defaults to the object that fired the event. The final argument is an object containing additional configuration options. Because we are listening for a tap event, we must specify the DOM element which will respond to the event, in this case the body. Even though the panel object won't respond directly to raw events triggered in the DOM, it is possible to create custom events and have your components listen for these. To demonstrate this, I'm going to create a subclass of the panel, which will add a custom event called Interact. I'll define the subclass in its own JavaScript file named interactivepanel.js, and I'll just make sure that this file is loaded in the head of my index file. I'll begin by pasting in the init component function. JavaScript does not provide a super function to call the current method in the superclass. So instead you have to drill through the prototype chain and explicitly call the function. That's what this long line does, so at the moment this subclass adds no functionality of its own. So let's customize it now. The init component function acts as an initializer, So customizations made here will be applied to the interactive panel at the point of creation. I'll add a new interact event here by calling the add events function. Then I'll add a listener to this panel's element. When the tap event is fired on the element, I want it to trigger the custom interact event on the panel. The interact event does not occur within the DOM. It's just a made-up event, but that means that an interactive panel can listen for this event directly. If I jump back into my index JavaScript file, I can now change my instance of the panel class to be an instance of the interactive panel class. Previously, if I wanted to listen for a DOM event, I had to go through the element or body associated with the panel. But now the interactive panel can listen for an interact event directly. For now, I'm just going to create a simple handler that logs a message to the console. If I open this up in a browser, then you should see a message when I click on the panel. Note that the addListener function has a shorthand. You can also call on, and it will achieve the same effect. I can refactor this example a little further by moving the anonymous function into a property of the object, then referring to this in the handler. This syntax looks neat, and it reads almost like English. Event panel on interact, report event. There is another function for attaching listeners called addManagedListener, and it too has a shorthand, MON. This is an abbreviation for managed on, and we already saw that on was a shorthand for addListener, so it figures that managed on is a shorthand for addManagedListener. So far, my custom interact event is not looking especially useful. It simply fires whenever I tap on an interactive panel. Next, I'm going to enhance this event so that it is fired when the panel is double tapped, swiped, scrolled, and a whole host of other events. First, I'm going to move this inline handler function into a property of its own because I'll want to reuse it for each of the other events. Next, I'll paste in the list of events that I want to trigger the custom interact event. If I refresh the browser now and click on the panel, you should see that the console logs a great number of events very rapidly. In the next step, I'm going to add a template so that we can see exactly which events are being triggered. At the moment, my interactive panel is completely blank. I'm going to add a template so that it can report each event as it happens. I'll begin by pasting my template into the body of my index.html file. I'm using a text area with the ID of report interactions. Back in my JavaScript file, I can instantiate an X template with the from function, passing the ID of my text area. Finally, I'll set the styleHTML content property to true to apply styling to the template. My template includes placeholders for each of the events that trigger the interact event. To make it work, I'll need to create an object with each of these properties defined. I want to initialize each count with a value of 0, so I'm going to create a function called resetStats. This defines an eventStats object with a 0 property for each of the events. I want to make sure that the eventStats object is initialized from the beginning, so I'll call resetStats at the end of the initComponent function. Finally, after initializing the statistics, I want to render the template passing the eventStats object. If I refresh the browser now, we should see that the template has been rendered, and all events have been triggered 0 times. But nothing appears to happen when I click on the panel. So let's modify the handler for the interact event so that it updates the statistics and re-renders the template. Note that when the interact event is fired, it passes the event type and the event itself. This means that we have access to these inside of the handler function. I can update the log message to include the type of the interaction. Now, when I click on the panel, the log messages include the name of the event. Using this, I can increment the count for that type of event, then update the template. If I refresh the browser now, you should see that the number is incremented for each type of interaction when I tap, double tap, scroll, swipe, or trigger any of the other events that fire the custom interact event. The add events and add listener functions are both defined in the observable class. If you look at the object hierarchy, you'll see that the component, the container, and the panel all inherit this behavior. So all of these objects can respond to events if the appropriate listeners are added. Next, I want to look at a special case, the button. It's fairly safe to say that a button's reason for existence is to be clicked. You don't have to worry about listening for swipe or pinch events. If you want to trigger an action when a button is clicked, you can just assign a function to the handler property. Here I've created a reset button and docked it to the bottom of the viewport. When the button is clicked, I want to reset the statistics on the event panel. I'll implement this by assigning an anonymous function to the handler, which calls the reset stats function on the event panel. If I refresh the page now, you should see that the button is at the bottom of the page, and when I click it, all of the counters are reset to 0. There are a few options that allow you to modify the behavior of listeners in Sencha Touch. For example, by setting the single property to true, you can create a listener that responds to the first event, then removes itself. You can also set up a listener so that its handler fires after some interval of time has passed. There are two alternate mechanisms for this. You can delay the handler, or you can buffer it. To demonstrate the difference, I've created two separate interactive panels, one with a delay and the other with a buffer. The panel on the left has a delay. When I tap on it, you should observe that there is a 2-second delay before the event is registered. Now, I'm going to tap on this panel 1, 2, 3 times. Note that each click is counted after a 2-second delay. When a listener is given a delay, its handler won't fire until the specified interval has elapsed. It doesn't matter how many times the event fires, the listener will always be handled after a delay. The panel on the right has a buffer of 2 seconds. When I tap on it, again, the event is registered after a delay. But watch what happens if I tap it 3 times in less than a second. 1, 2, 3, wait. There, it's only registered 1 of the clicks. When a listener is buffered, its handler won't fire until the specified interval has elapsed. Where it differs from the delayed listener is that only a single event can be queued at a time. If the event fires again while a handler is waiting to fire, the original handler is not invoked, but the new handler is scheduled in its place. In this screencast, we learned that components can't hear events in the browser, but their element and body can. I showed how to create custom events and how to listen for them. I also showed how listeners can be modified to respond one time only with the single option, or to fire their handler after an interval using either the delay or buffer options. Check out the code from GitHub to study the examples shown in this screencast. You can also find a live version of the interactive panel demonstration. Play around with it and it should help to clarify which touch gestures trigger each event.